grid below, by shading the region defined by the inequalities, x is less than 4, 2x plus y is greater than 6, y is greater than 1/3 x. Label the region R. So what that means is we're going to just draw these lines. So x is less than 4. We're going to draw the line x equals to 4. It's going to be a dashed line because of the less than. It's not equal to it, so it's a dashed line. So x is equals to 4 is this line here. And it's a dashed line because of the inequality sign is less than. So it's not less than and or equal. So this line here is x equals to 4. Right, next we have the line 2x plus y is greater than 6. We write that as 2x plus y is equals to 6 for now. Y is going to be 6 minus 2x because we want to make just y the subject, so we can plot the line y is 6 minus 2x. And to plot this line, we need to find values for the coordinates for this equation of line. So we have, let's say x equals to 1. I would have y is 6 minus 2 lots of 1. And that would give us 6 take away 2, which is 4. So our first coordinate we can plot is 1, 4. Next we write x is equals to 2. So we would have 6 minus 2 lots of x is 2. So 2 lots of 2. 6 minus 4. That would give us 2. So our second coordinate that we can plot is 2, 2. We always need to have at least 3 values when we're plotting a straight line. So we have, let's say x is 3, and now y is 6 minus 2 lots of 3. Now 6 take away 6. That would give us 0. So the third coordinate we could have is 3, 0. So if I plot those 3 coordinates, they should fairly be on a straight line. Also, the intersect is 6. So if you think about it, I'm going to have a y-intercept at 6. So I'm going to plot 0, 6. We've got 1, 4, 2, 2, and 3, 0. Now that's also going to be a dashed line simply because it's an inequality. Okay, and this is y equals 6 minus 2x. Right, finally we have a third line to plot, and the third line is y is greater than 1/3 x. So I'm going to write it as an equal sign for now. This is the only time you can write it as an equal sign. So if you were solving this, you've got to keep the inequality the same. But because I'm trying to draw the graph, I can write the inequality as equal, and I just substitute in values for x. So when x is 0, y is going to be 1/3 of 0, which is 0. So our first coordinate is 0, 0. I'm also going to choose a value for x that's divisible by 3. So I'm going to have when x is 3, 1/3 of 3 is 1. So I'm going to plot 3, 1. And finally, when x is another multiple of 3 is 6. So 1/3 of 6 is 2. So we can plot 6, 2. So I've got 0, 0. So 0, 0, 3, 1, 6, 2. I'm going to represent that again by a dashed line. So this is y equals 1/3 x. Then I have to start shading in some regions. So the first region I need to find out is this region here. Let's just use the same color. X is less than 4. Now, if this is the line, x is less than 4 is going to be this side of the graph. Okay? And then we've got y is greater. This line, we have y is greater than 6 minus 2x. If it's greater, it means it's going to be above that actual line. So it's greater is going to be this part of the graph because it's greater. So, and finally, y is greater than 1/3 x. So 1/3 x is this line, which is this bit here. Now, obviously, in the exam, you're not going to start shading everything in, because if you do that, the problem you're going to have is you won't be able to say where you're shading altogether, because you need to actually label a region R. Now, the region R is where all the colors or all the shading actually overlap each other. So I'm expecting 3 shades. So if I undo, as you can see, the region everything is shaded is this section here. So if you notice, the region where I've shaded all 3 colors is this bit here. So that bit, I could shade it in if I want to say, well, that's the part that's satisfied the inequality. You don't need to shade it in, but it's just helpful to say, well, this is the part that satisfy all 3 inequalities. And that's it really. So that section is R.